Hey guys, welcome back to my channel. So today I'm going to start with a new subject, that is Biostatistics. This is for 8th semester. So I'll cover the full 10 marks for the first unit of Biostatistics. So I'll start from the first question, that is what are the measures of dispersion, and explain their significance with suitable example. So the answer is the mean, median or mode is usually not by itself a sufficient measure to reveal the shape of the distribution of the data set. So we also need to measure that they provide some information about the variation among the data set value. So there are the ways of showing the dispersion is absolute measure of dispersion, that is number A. In that the small ranges are number 1 range, quartile deviation, mean deviation and standard deviation. So number B, that is relative measures of dispersion. In that 1 coefficient of range, number 2 coefficient of quartile dispersion, number 3 coefficient of mean deviation and number 4 coefficient of variation. In that number 1 range, so the difference between the maximum and the minimum observation in the data set value is known as range. So the range is equals to highest minus lowest, where R is equals to H minus L, where the coefficient of range, the measure of distribution based on range by its of the coefficient of range, are also known as the range of coefficient of dispersion. And the coefficient of range, the formula for the coefficient of range is equals to range divided by height plus lowest into 100, where example that is 5, 10, 15, 20, 7, 9 and 12, 17. In that the 5 value is the lowest value and the 20 is the highest value, where for the formula for range is H minus L. So H is 20, that is highest value, and L is lowest value, that is 5. So 20 minus 5 is 15. So the answer for range is 15, where the coefficient of range is range divided by highest plus lowest into 100. So what is range? The range is 15 divided by height, where height is 20 plus lowest, that is 5. So we'll add 20 plus 5, which is 25, so into 100, and we'll get the answer, that is 6. So the significance for this, it gives a rough answer and is not based on alternative observation, so it is affected by the sample flocculation. In that number 2, the semi-quartile deviation, so the half distance between the 75th percentile, that is third quartile, which is Q1, and 25th percentile, that is first quartile, which is Q3, is a quartile deviation or interquartile range. It is also known as the distance between the quartile Q3, that is, and lower quartile Q1, where the interquartile is equals to Q3 minus Q1, where the quartile deviation is Q3 minus Q1 divided by 2. So the coefficient for quartile deviation, a relative measure of dispersion based on the quartile deviation. So the coefficient of quartile deviation is the quartile deviation divided by median into 100, where the quartile deviation is Q3 minus Q1 divided by Q3 plus Q1 into 100. So the interquartile range, that is Q3 minus Q1, which is 25 minus 5, will get 20, and semi-interquartile range Q3 minus Q1 divided by 2, where the Q3 minus Q1 is 20, we got 20, so divided by 2 is 10. So the semi-interquartile is 10, and the coefficient of quartile deviation is Q3 minus Q1 divided by Q3 plus Q1 into 100, where the Q3 minus Q1 is 20 and Q3 plus Q1 we got 30 into 100. The answer is 66.6. So the coefficient for quartile deviation is 66.6. In that, number third, that is mean deviation. So the average of absolute value of the deviation from the mean, median or mode is called a mean deviation, and the coefficient of mean deviation, where the relative measure of dispersion, so we get by dividing the mean deviation by mean or median, is called the coefficient of mean deviation. So the formula for coefficient of mean deviation is mean deviation divided by mean or median into 100. For example, let's see the ages. So 5 boys in the class, that is 12, 13, 14, 15, 18. So where the mean is 12 plus 14 plus 14 plus 15 plus 18 divided by, that is 5, because in the class the boys are 5. So divided by 5 and we got the answer 14.6, where the mean deviation, that is sigma x minus x bar divided by n, where 12 minus 14.6 plus 14 plus 14.6. If you were asking me about 12 minus 14.6, how we got, in the sense 12 is the mean, that is where the boys are in the class. So 12 minus, we got the mean, that is 14.6. So 12 minus 14.6 plus, and here in the class we know 14 is also there. So 14 minus, that is we got the mean 14.6, same we have to kept here 14 plus 14.6. So divided by, overall these are divided by 5, because in the class the 5 boys are present. So the mean deviation, totally the mean deviation is equals to 1.52, where the coefficient of mean deviation is equals to mean deviation divided by mean or median into 100, which is equals to, we got the median deviation, mean deviation, that is 1.52, or we can also divide by mean or median. So the 14.6, we got the mean, that is 14.6 into 100. So the answer will become 10.41%. So number fourth, that is standard deviation. So standard deviation is calculated as the square root of the average of the squared deviation that is taken from the actual mean. So it is also called as a mean root square deviation, and it is denoted by sigma, that is sigma, where the sigma is equals to summation of x minus x bar whole square divided by n. So if the standard deviation for ungrouped data are having any frequencies, this can be calculated as rho, that is sigma frequency x minus x bar whole square divided by n, where sigma fi equals to n be the total frequency. And if the series is individual and ungrouped, then the standard deviation is calculated by the following formula. So by using assumed A method, so rho is equals to summation d square divided by n, whereas minus summation d whole square divided by n, where d is equals to x minus a, where n is equals to number of observation and a is assumed mean. In discrete series, the standard deviation is calculated by using assumed mean method, that is rho is equals to square root of summation frequency x minus a, that is assumed mean, whole square divided by n, that is number of observation, minus summation frequency minus x minus a, that is x is mean, a is assumed mean, divided by number n, that is number of observation, into whole square, where rho is equals to square root of summation f d square divided by minus summation f d divided by n whole square, where the coefficient of standard deviation is rho divided by x, that is assumed mean or mean, etc. So the variance square of standard deviation are called variance. In the simple form, the square of standard deviation are called variance. So the fifth one, that is coefficient of variance. So measures of spread that describes the amount of variability relative to the mean. So the coefficient of variation is standard deviation divided by mean into 100. For the example, so here is the example for the coefficient of variation. So you can see the example for this. So here the next question describes different measures of central tendency. So central tendency is measured by averages, and these describes the point about which the various observed values cluster. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within the set of the data. So measure of tendency, sometimes called as a measure of central location, and the mean, median and mode are all valid measures of the central tendency. So but under the different conditions, where mean arithmetic average of a set of number, where geometric mean and harmonic mean, in that mode, number second mode, the number of that appears most often, and the median, the value whose occurrence lies in the middle of the set of the number, that is half above and half below, middle number. So in that we'll start with the first, that is mean. So in that, number A, that is arithmetic mean. So it is the sum of the set of observation by positive, negative or the zero, which divided by the number of observations. So it is denoted by x bar, where the x bar is equals to sum of the set of the observations divided by number of the observation. So x bar is equals to x1 plus x2 plus x3 till xn or infinity divided by n. So number second, or number B, that is geometric mean. So the mean, geometric mean is defined as a positive root of the product for the observation. So geometric mean is x1 into x2 into x3 till xn divided by square root 1 by n. And the harmonic mean, so the harmonic mean is used to calculate the average of set of the numbers. Here the number of element will be averaged and divided by the sum of the reciprocals of the element, where the harmonic mean is always the lowest mean. For the formula for the harmonic mean is n divided by 1 plus x1. So 1 divided by x2 plus 1 divided by x3 till 1 divided by xn. So where x is the individual score and n is the number of scores. And the examples for the arithmetic, geometric and harmonic mean for the following situations are, so this is the example for arithmetic, geometric and harmonic mean. So this is arithmetic mean, sum of the all observation divided by number of observations, and geometric mean, and lastly harmonic mean. So we'll move, that is number second, median. So the median is the value that falls in the middle when the observations are observed into either the ascending or the descending numerical order. If n is odd, median is middle number. If n is even, the median is average of the two middle number. Means if the number will get 6 or 5, number 5 is odd and number 6 is even, so we'll get odd, that is 5, so 1 to 5, so we'll pick up 3 as a middle number, and 1 to 6 we have to divide 3 by 4, so we'll get the middle number of the average. So to find the median, first the data set must be sorted into the either ascending or the descending numerical order, then select the median. For examples for the median are, so here is the example. So as I have said already, if the number is even, that is 1 2 3 4 5 6 7 8 or 12, so the median is 4 plus 5 divided by 2, where 9 by 2 is 4.5. And number third, that is mode. So mode is the value of distribution for which the frequency is maximum. In other words, it is made of the value of variable which occurs with the highest frequency. So for the example, find a mode of data. You know, this is the example for the mode which is occur mostly. Repeated numbers we will get. And standard error of mean. So the standard error of mean is also called as a standard deviation of the mean. It is a method to use and estimate the standard deviation of a sampling distribution. So the standard error of mean is also used to estimate the sample mean dispersion from the population mean, and the standard error along with the mean sample, it is also used to estimate the approximate confidence interval for the mean. And the estimation with the lower standard errors of the mean indicates it has more precise measurement. The standard error of mean is always smaller than the standard mean. So the formula for the standard error of deviation, that is standard deviation divided by root of n, where standard deviation is also known as rho, and divided by root of n, where rho is standard of deviation of the population and n is size of the sample. So example for the standard error of deviation. So here are some example questions for 10 marks question and answers. In that, number 1, explain types of correlations and correlation coefficient. Give suitable example and explain the correlation, type of correlation and its application. So define and explain the correlation with example, and explain the Pearson's coefficient and its correlation with example, and even the explain the Pearson's correlation and Spearman correlation. So I'll start the answer, that is correlation. So the correlation is a statistical tool that helps to measure and analyze the degree of the relationship between the two variables. So the correlation analysis deals with the association between two or more variables. So the types of the correlations are positive and negative, linear and non-linear, then simple, multiple and partial correlations, where the correlation coefficients are, so the ratio that indicating the degree of relationship between the two related variable, where for the perfect positive correlation the coefficient is a correlation of +1, where the perfect negative, that is -1, and positive coefficient of correlation varies from 0 to +1 and the negative to 0 to -1, and the absolute no correlation, that is no linear correlation. or a weak linear correlation which is close to 0, where the positive correlation when the values of two variables move same direction correlation is said to be positive, that is an increase in the value of the first variable result in the increase in the other variable or vice versa are said to be positive. Example, the temperature and the volume, where the negative correlation, so it can be said to be negative when increase in the first variable which leads to decrease in the second variable, or is also vice versa. Example, pressure and volume. And a really linear correlation, so when the amount of the changes in the variable leads to the constant ratio of the change in the other variable are said to be linear. And non-linear, there one variable is not constant to the ratio to change the other variable. And the simple, that is if the relationship between the variable, if are only two variables, then the correlation is said to be simple. And the multiple, it is said that multiple correlations we measures the degree of assumptions between the variables on one side and all other side of the variables together on the other side. Where the partial correlation, we study the relationship about one variable with one other variables, presuming that the other variable remain constant. Where the application for correlations are pharmaceutical industry to see the effect of the drug where certain parameters, and automobile sector how the price fuel affect the sales of the car, and the banking sectors how the interest rate affect the economic growth for the country, and scientific research to see the change of the one parameter, that is the other parameter, and healthcare sectors, that is health recovery can be analyzed by the time of the physiotherapy exercises. And Carl Pearson's coefficient of correlation is also extensively used in the mathematical method in which the numerical representation is applied to measure the level of the relation between the linearly related variables. So the coefficient of correlation variables of two variables is obtained by dividing the sum of the product or by corresponding the various items of the sense. So the standard deviation and number of pair observations, if x1, x2, x3 to x1 were the first variables and the y1, y2, y3 are the other variables, then this corresponding deviation would be summation of x and y. So the example or the formula for the variations are, so it is a clear form to above the formula, that is summation of x and y is positive or indicates the positive correlation between the two variation or vice versa. So the coefficient of correlation is also calculated by the following formula. So this is the formula for the positive correlation. So this is the calculations in the first unit. So explain the measures of central tendency, calculate the mean and the standard deviation for the following data, that is systolic BP of volunteers, and this is the systolic BP which presents in mm and Hg, and the frequency so 91 to 100, 101 to 110, 111 to 120, 121 to 130, 131 to 140 and 141 to 150, where the frequencies for these are 8, 14, 20, 26, 24 and 18. So the frequency, so we have to add the frequency and the answer will get 110. And x, what is x in the sense? So we have to choose the middle number, that is median 91, between the 91 to 100. So the middle number is 95.5. In 101 minus by 110, so the middle number will be 105.5. In 1111, that is 111 to 120, in that the middle number comes 115.5. So this is how the x we will find out. And fx, so what is fx? So we have to multiply the frequency and the x value. So 8 into 95.95 we will get 764, and 14 into 105.5 we will get the answer 1477. So this is how we will convert the multiply the f into x, and will get the answer, that is 13,685. and number next, that is x minus x bar. So x we know, that is 95.5, and we have to calculate x bar. So in that, the formula for x bar is mean. So mean is, the formula for mean is summation of fx divided by n, where we got the value of fx, that is 13,685 divided by what is f. F in the sense number of frequency or the number of wages. So n is, will count the n number of observation, that is 110, and we'll get the answer 124.4. So the x bar we got the x bar, that is 124.4. So now we will minus the subtraction of, will do the minus x bar, that is, what is x? 95.5 minus x bar. What is x bar? That is 124.4. Also we'll do the next one, that is 105 that is, this is x now, so 10.5 minus 124.4. so this is continuously we're going to calculate the x minus x bar. Then coming to the next, that is x minus x bar whole square. So now we have to take 28.8 whole square. This is x minus x bar na. So we have to take 28.9 into 28.9. So we'll get the answer 835.21. Remember, I'll say once again, this is x minus x bar. So x minus x bar whole square, we know the 18.9, that is x minus x bar, and we have to do whole square into. So 18.9 into 18.9 will get the answer 357.21. So for 8.9 into 8.9, 79.21. So this is how we're going to continue the x minus x bar whole square. After we'll getting this x minus x bar whole square, we have to multiply with the f, that is frequency. So f, that is frequency, into x minus x bar whole square, and will that get the answer on that time 8 into 8 3.5 into 2 1, and we'll get the answer 6681.68. So I'll say number second, that is 14 into 357.21. So we'll get the answer 500.94. This is how we're going to continue with the last, that is 8013.78, and we're going to add this all. Lastly, we have to divide, that is standard deviation. For the standard deviation, the formula for the standard deviation, that is summation of f and x minus x bar whole square divided by n. So we got 24.2691, which is x minus x whole square divided by the number of observations, that is n. What is n? 110. So square root of 220.62, we will get the answer, that is standard deviation 14.85. So in that number second, that is explain measures of dispersion, calculate mean variance and standard deviation. So in that, the height and the frequency is also available. So 135 to 140, same here what we have done to the previous answer, here also is the same, that is height, frequency, x, frequency into x, x minus x bar x minus x bar whole square and frequency into x minus x bar whole square. So note down, this is same as the previous answer. And this is the another question. So describes the different measures of central tendency, calculate mean and the standard deviation for the given data on mid-arm circumference centimeter of 16 children. So in the question he didn't give the frequency for the distribution, so in that we will not find out the frequency. So we have to calculate the x minus x bar, that is mean, and the standard deviation, that is x minus x bar whole square. So this is the x and x minus x bar and x minus x bar whole square. So the mean, that is x minus divided summation of x divided by n, where 192, by adding the x will get the answer 192, and the total numbers are 16, that so we have to divide by 16, where x bar will come 12. So in that 12 minus 14 minus x bar, what is x bar? That is 12. 14 minus 12 is, will get the answer 2, and 12 minus 12 0, 13 minus 12 1. So this how we will going to continue, and x minus x bar whole square, 2 into 2 4, 0 into 0 0, 1 into 1 1, 2 into 2 4. This is we will going to do the answer, and finally the by adding the x minus x bar whole square will get the answer, that is 13. So for the standard deviation summation of, so here is the difference answer because the frequency is not available in the question. So the summation of x minus x bar whole square divided by n. So what is x minus x bar whole square? We got the answer, that is 30. Root of 30 divided by number, there are 16 total number, 16 numbers are there, so divided by 16, so root of 1.875, and the answer is, for the standard deviation, the answer is 1.369. So here we have fully completed the first unit, 10 marks question and answers of biostatistics. So tomorrow I am going to continue with the other subject. So please do like, share and subscribe to my channel.